can use the directional derivative to estimate the change in a function in some given direction u. So df, this is meaning the change in the function value f, is equal to this expression, which is, this is just the directional derivative. And we're assuming u here is a direction, so that means we need to turn it into a unit vector. It's not already a unit vector. ds is, this is the distance that we go. And so this example right here, estimate how much the value of f of x, y, z is y sine x plus 2yz will change to the point 0, 1, 0, moves a tenth of a unit towards the point q is 2, 2, negative 2. What do we need to do here? We need to figure out, let's see, we need the gradient. The gradient of f is going to be, the x derivative is going to be y cosine x. The y derivative here is going to be sine x plus 2z, and the z derivative here is going to be 2y. The gradient evaluated, we need the gradient evaluated at the point, is going to be, plug in 0, 1, 0 here. So cosine 0 is 1 times 1 is 1. Sine of 0 is 0 plus 2 times z is 0. That's 0. 2 times y, 2 times 1 is 2. Now we need our direction vector. So note that our vector v from P to Q, we go up 2 units in the x direction, we go up 1 unit in the y direction, we go down 2 units in the z direction. So this is the vector that we want to, that we are going to get our direction from. So to find the direction, what do? We need to find the magnitude here. I'll let you check for yourself that you get 1/3 for the magnitude. So our direction vector is, divide this by 3, 2/3, 1/3, negative 2/3. Okay, so at this point then, what we need to do here is directional derivative, do our gradient dot product with u, and then multiply by the distance. So to finish this off, gradient is 1, 0, 2, dot product 2/3, 1/3, negative 2/3. That's the directional derivative, all of this times 0.1. And when you crunch this out, you get 2/3 minus 4/3 is negative 2/3 times 0.1. So this is how much when so that is, I guess, negative 0.2 divided by 3. That's going to be our estimate for the change in our function f.